right. Hey, everybody. We are back this afternoon here in the U.S. Central Time for our next session. And today, at this time, we are presenting Azure administration using Azure Functions and Logic Apps with David Wiggs, the man with probably the most memorable blog that I have heard about in a long, long time, awshole.com. Classic. So David, I think we've actually in the chat, we've had a lot of people asking about Azure content and things like that. That's kind of the theme of the afternoon. So what I'm going to do is just hand it over to you here and tell us all about Azure Functions and Logic Apps.
Yeah, great. Thanks, Lee. Thanks for the hat tip on the blog. Yes, as you'll see, that's the website I blog at when I have time. And today we've already had a lot of demonstrations about how to use tools to manage Azure resources and how PowerShell is in that tool belt and how it incorporates into that ecosystem. Today we're going to keep it really vanilla. We're going to try and keep everything inside the Azure stack, for lack of better terms. And so we'll go ahead and jump right into it. Please do send along your questions into the chat. I'll answer them after the session's done. But if you were able to attend the sessions earlier, you may have seen this slide earlier as I co-presented with a colleague on the session. But my name is David Wiggs. I am in security architecture and engineering at Bain & Company here in Chicago. My favorite PowerShell modules, Azure AZ module, will be known heavily today. Import Excel, Azure AD, and more recently, I've been getting back on the horse of PowerShell. That kind of describes my personality, I feel like. As you may guess from my domain, I spend a lot of time in Azure. I've gotten a couple of certifications recently to try and get some feathers. But I also like to say I used GitHub and Git Command today, so I'm just on the same playing field as those that are starting out their PowerShell journey as well. A little bit about me personally. I'm a foodie. I love pizza. I love food, hot dogs, tacos, you name it in Chicago. Hopefully I've tried it. And if you ever see me, buy me a beer, talk about math, and we'll get deep down in a dark place there. But yes, find my blog down there. Always happy to see comments. And so, what will you hopefully gain from this talk? I like to think that we are going to gain a new understanding of a classic problem, focusing on speed versus security. What's the best trade-off of allowing developers to move fast, or having a very airtight system where nothing is ever going to go awry? We're going to use this understanding to maybe develop a new framework, somewhat of an event-based or an event-driven object state configuration approach to Azure resources. And it's not necessarily just virtual machines or operating systems, so that's kind of why this is a little bit unique. I'm definitely going to take some of the previous talks, techniques into my own tool belt, but this is a little bit different approach. We're trying to keep everything inside Azure. And we'll see how this framework to a desired state configuration it fits into the big picture and how we can use this to really actually add value to an organization or increase security posture. And then hopefully at the very end, I'll be posting a link that has all of this code that I'll go over in case you wanted to leverage something like this in your own environment. I'll say disclaimer of the, hopefully you don't break anything, and I'll help you through it if I can, but no promises. Anyway, in a world where these are some links that I can send out to the chat later, you can build your own fiber internet. Lydia has done this by herself to build gigabit network with backhoe. You can buy jet engines online. You can start a serious conversation about flying to the space station. You can lose $440 million in 45 minutes. In this world, we still have to provide guardrails to developers to move fast but remain secure. So this is this tried and true problem, right? We've come all this way, but we still have some of the fundamental problems that we deal with on an ongoing basis in the IT community, whether you're in operations or security or infrastructure architecture. And because of this, a typical rationalization of incorporating security, it looks something like this. I know that I'm being a little bit crude here, but it helps for the flavor of the talk. Developers are going to develop, right? And so because of that, we're going to by nature not really trust them. We're going to implement lots of control processes to make sure it's secure. We're going to put this big wall up. Probably this wall is a metaphorical wall. It really consists of all of our tools and processes, X, Y, Z, that basically say, yes, we have security. And everything on the other side of the wall has to be secure because of our big wall and our documented processes, right? This is necessarily illogical, but it basically implies that the value is delayed by incorporating security. It's a blocker. It's something that we have to get over. it's usually viewed as never a value add. It's always viewed as a cost center. Same story as IT, but even worse in some cases. And so I think this is a terrible news for everyone. This basically, it allows for security professionals to operate in a silo, and having distrust in developers basically never allows for collaboration between the two. And so, when you look at this in the cloud, this becomes so much worse. The reason being is because even though we're working in the cloud, we have a different set of goals and a different set of situations that we're having to take advantage of. Immutable infrastructure is great. Containers are almost the solution to everything, but sometimes you want to give a little bit of slack in the system or have some graceful forgiveness, right? And that's not always the right answer. So we can't choose a large hammer like something container-based deployments to fix everything to do with configuration state. Just-in-time environments might not be evaluated. So if we get slick like with some of Adam's pipelines, and we build and tear down things really quickly, perhaps some of our scheduled security controls might not evaluate what's happening. And developing to catch that's possible, but that's kind of the point of this talk. And last, quite a literal cost to idle resources if something's broken or effective security controls are blocking development. And a typical example is if a security requirement is unfulfilled and development resources are just sitting there dormant. Not even the people, let alone the infrastructure. There are dollars that are spent if the infrastructure is a time-based consumption. And so, hopefully, this revival of a new problem or the revival of the same problem of speed versus security, we'll be able to realize this paradigm shift to strike a balance between secure operations and minimizing a time to value. And so this is all kind of leading up to a situation I'm describing as what kind of a typical day in the life for someone who's in maybe the DevOps world looks like. And when I sat back and I thought about this, I attended Summit a couple of years ago, and there was a quote in one of the keynotes that says, "PowerShell is the center of the universe, and everything else just revolves around it." And so now we are going to talk about how we approach this problem using this desired state framework. And so when I drafted this out, it wasn't until after I drafted the slide that I actually came up with the title of it. Hopefully you'll see why that's the case. And so here is, kind of, let's just call it someone that's grumpy in security up on the top right corner of your screen. Usually someone, a one-man army, right? No, one woman, one person army. And then we have developers that are going to develop. It looks like one of them down there is had a day. And of course, we still have our wall that is between us that, makes sure that our developers are, acting accordingly, doing good things, and not necessarily exposing all of our good secrets. And so it's now we're working from home, and that's giving a lot of people ideas. For example, an idea to perhaps work from a coffee shop, or work from a different location, or work from their cell phone as their internet connection. Things like this are much more common nowadays, and so a new set of problems happens. But more or less, an idea to access my SQL database that's behind our wall, but because of this changing time, I'm going to poke a hole through it, because in a typical scenario, this developer is likely a contributor or higher role to the infrastructure, because obviously he's managing it. He's interacting it with on a daily basis, setting schemas, etc. And so because he has the role of a contributor or higher or what have you, he has the ability to poke a hole in this wall of ours in order to do what he needs to do. That's not a bad thing. We probably did that by intention, providing him the necessary tools to do his job, his or her job. But as we probably all know, developers aren't exactly good at cleaning up all the time. So this hole remains persistent. So what can we do about this? Luckily, in our space, Azure, we have a couple of tools to use. Namely, Azure Monitor is a key thing here, and the activity log. Two things that I strongly believe are overlooked in the Azure ecosystem. The activity log is a centralized place that logs all of the management plane activities. So this management plane activity, if we put a hole in here, we'll see that there's actually a log of it, and we can do something with it. But because of that, we can shift that log information into Azure Monitor and end up with some JSON output. This JSON output is good because it's an artifact for us to use as administrators to what's happened and who did what on what resources. And that's, you know, a perfectly good setup to say, if we want to determine this logical flow of things, why don't we set it all to a logic app? A logic app in Azure is more or less it's a quick way to do mediumly complex things. That's what I would say. There's a whole backend that you can use if you'd like it to be strictly text. You can do very complex things, put it under source control, or you can use the designer view. That's what I'll be doing today, to do pretty rapid, you know, quick analysis of structured data. And we're going to get some JSON output out of this when we look at it. And again, now that we have kind of a raw understanding of our data, the alert data that's come through, we can actually pass that to an Azure function. Azure Functions are very good at doing things now. And now that Azure Functions can run, and I just saw this yesterday, actually, I noticed it organically, the PowerShell 7 runtime, previously was PowerShell 6.2. Again, we're going to get those AZ commandlets by nature. We can enter other resources that might contain configuration data, like Azure files. We can obviously set and do operations, do all of our set commands on our infrastructure. So as you can see, PowerShell sits in the middle of all of this, but it's truly what makes everything work. I consider everything else to be plumbing. PowerShell is really the champion in the game here. So this is the framework that we're going to go ahead and take a look at, and we're actually going to go ahead and implement this as our demo. So I believe that the slides are over here, or very close to being over. You know, taking this back to a more philosophical or strategic level, if we store configuration as code in a way that's not only infrastructure here, I'm making a specification to be configuration, we can interact with it easily, both from programmatic but also, you know, desktop tools perspective, making it easy. And I'm talking about, you know, let's maybe not have our eyes bleed all the time looking at JSON. And we can use roles effectively. We can take out the passwords, we can take out keys, we can take out all of the sequence management that sometimes deters from automation. And we can remove human dependencies to basically lower the time and lower administration effort with this. Doing these things in general will promote secure service. I think that's what my goal is as an infrastructure steward, as a cybersecurity steward. You know, enable people while encouraging security. And this is what we're going to try and capture again in this set of demos. Oh, yeah, like I said, we're going to get into it. Those are all the slides, so hopefully that was pretty quick. Now we'll have time to kind of play around, and I'm going to go shift back and forth between some of my guidelines here, but also we'll be going into the Azure portal, into code, and doing all the good stuff. So to start out with, we're going to be creating an Azure function, and the first thing we got to do to that is create the runtime, enable an app service plan, and do all of those things. So without further ado, I've done a little bit of cheating here. I've just logged in already into my Azure portal. And because I've done this once, I'm actually going to be using the second resource group here, so I don't get confused. But I've already created a SQL Server here, and the merge account, I've cheated just a little bit. Those are kind of assumed to be already created. First thing to do here is, in order to enable our framework, is we're going to make our app service plan. And like I said, I promised that this would be free in the abstract. So yes, we're going to go ahead and create an app service plan. And we are going to use a Windows app service plan. We are going to change it into being shared infrastructure dev test, right? We get a gig of RAM on shared processors. In this case, I'm not really worried about data sensitivity. I'm worried about cost. But if you are, you can maybe make this a consumption plan. If you got the wallet for it, you can even make it a dedicated or isolated. But you know, that's outside the scope here. For this, we're in development subscription. It's an application service plan, and we're going to call this Windows Free 01, right? That's the information we contain here. Don't yell at me for not using tags right now, and we'll go ahead and create this. And this should create fairly quick. And once it does create, again, for those that aren't necessarily as familiar with the application service plan is kind of like the compute behind our function. So we have to give our function a place to do operations on. And so you can see this was created quickly. Excellent. Go back into our resource group again here, and we can see that our free application service is now available to us. Now we're going to go ahead and just create our function object. I know that there are many people that are probably cringing that I'm doing this through the portal. There are 12 dozen different ways to skin a cat these days. To create things, I like to do a mix of both automation and in the portal, but this really kind of shows you guys what's happening in the background and what objects I'm creating. This function, let's call this set as AZ SQL Server Firewall rules, and this is the second time I've done this. Exit the second time, and we are going to make sure that we include PowerShell core here. And it, like I said, new goodness is PowerShell 7. That's relatively new, I believe. Central region, yes, that's where we'll be at. Skip over to hosting. A couple of things to do here. First, switching to app service plan. We're going to go into our free app service plan. And then if we take a look up here, I'm going to go ahead and create a new storage account for our function. And this is AZ app STO app 02. That sounds fine. You know, I'm not being too stringent with my naming conventions here, but this is the storage account that the function is going to need. I'm not going to do any monitoring right now. Again, no tags. And we'll go ahead and create this. I realize we could have done all of this within the VS Code IDE. You could do this inside Azure DevOps. There's a number of different ways to provision this, but I wanted to take a pause and show while this is provisioning some of the notes that we have to follow here. So we already created our PowerShell core runtime. We've used our free app service plan. We have a couple of different things to do here now as well. We're going to need system managed identity, and we're also going to need to provide some what this allows us to do is avoid using secrets. And so that, to Jeff's keynote at the very beginning of our talks, managing credentials PowerShell is something that we all should get better at doing. And I think that basically means if there's ways that I can do things without necessarily using credentials, that's the preferred way. And so if you haven't seen this trick, maybe this is one of the things you can take away, if anything. But we have here. And since Azure has revamped kind of the view of functions, you can scroll down and now you can see that identity blade inside here. What we're going to be doing is we're going to be turning on an identity for this function that basically allows it an identity to assume while it's running code. So that means, in theory, I don't have to authenticate, right? I don't have to manage an application registration. I don't have to manage secrets, rotation of them, etc. So yes, this sounds great. But in order to do this, we have to get role assignments correct. So let's go ahead and turn on our managed identity, and once we actually get an object ID, we can find this inside Azure Active Directory too. I'm going to go ahead and we can come back to this later, like add some role assignments. And so if we think about what this function is doing, let's take a look back at our diagram of kind of this framework that we're going to be assuming. Let's skip all the way through these animations. This function right here is going to be interacting. It's going to be receiving input from a logic. It basically tells me that this should be some sort of HTTP trigger. And it's going to be something that is storing configuration data. In this case, it's going to be an Azure Files. And it's also going to be interacting with an Azure object itself. So we're going to do our AZ commandlets. And so the specific object in this case is SQL Server. So what we're working with is an Azure Files, which is underneath a storage, and a SQL Server. And so we need to make sure our function has the appropriate roles so that when we used our managed identity, it has the permissions to do. And we can go into our Azure roles, assign a role assignment. Now here, watch what I'm going to do here. I'm going to do at the subscription level. In theory, this function might be used to maybe remediate all different kinds of SQL rule changes. That's what we're doing. And so let me go ahead and look here for SQL Server contributor. This role here will basically allow the service to administer or manipulate SQL Server firewall rules. We have only exposed the permission to manipulate SQL servers subscription-wide scope, but we could narrow that down if we wanted to. But we're leveraging roles basically rid ourselves of the need to do authentication. And as I before, we needed to basically allow the retrieval of configuration as function as well, because inside ecosystem here, this configuration data in the end look kind of like this. It's going to have our server resources and the approved list of firewall rules that we're going to have as allowed. If I look down and I select the resource data 002, storage account is where we are going to be holding our configuration. And then here, we're actually going to make it a contributor. I believe that will allow it to list keys, and that's what we needed in order to establish a context. Save here. Okay. So we've added our roles. We're almost done with the demo of configuring the function. We still haven't actually deployed any code yet, and we still haven't specified any variables. Now we're going to take a step back. We've done all kind of the pre-work in establishing the object configuration, and now we're actually going to step through some and how we can use Azure Functions to essentially provide some guardrails in the system when a user takes action on an object that isn't variable. So here we are in VS Code, and you can see that I've kind of already got this code stubbed out in a previous iteration of this. So I'm going to walk through this just to kind of show you guys what's happening with the PowerShell. So all the heavy lifting is happening in PowerShell here. All the rest is really just plumbing. And the main goal we have here is to basically have a function that can read config. And in our specific case, it is SQL Server firewall rules. Compare that to what's been recently done. And in our specific use case, we are going to rules that have been added that may not be as specifically allowed. And so if you're not familiar with Azure Functions, we have an HTTP binding where we're going to go ahead and trigger metadata and request data. This request data is actually the body. It contains our alert information. If back at our lifecycle, the logic app is actually sending some JSON here to our Azure function. So the first thing we do is we do some formal error handling. We make sure that we scope, right? And if this scope splits successfully, so that we were able to obtain a scope. If not, we'll go ahead and push up add request. The scope is basically some information that tells us what resource group and what resources were actually operated upon. So again, we're going to split those and take those values out of the scope that was passed in as part of the body. Let's make sure that our resource group name is available to us, right? And also that the resource group is there. So again, just a little bit more integrity validation. A little bit of verbose output here. I know the right host is probably killing some people, but try to look past that. So the next thing that we do, if we have the information that we need, something changed. The first thing is let's go ahead and get our allowed firewall rules. And so I'll show you now the dependencies that we need to set within our function as variables. We need to set the storage account resource group and the storage account name as application settings to our function app. That way we retrieve the storage account key. And because we have the contributor role on that specific storage account on our roles that we assigned, this command will work. Of course, we need the storage account key in order to proceed. Push failed dependency error if this fails. And then what we're going to be doing here is we're going to establish a new context to the storage account. Again, this is the dependency and everything working. And if we do have a context, we can pass it in to actually get the file content of that context. So in this case, it's assumed hard-coded here. That's okay. That we have an allowed AZ SQL Server firewall rules CSV. It's important that we recognize this as a CSV because we're going to be making use of import CSV here. You could make this in Excel if you wanted to, but then you'd add an external dependency on import Excel. As I kind of alluded to before, this CSV looks similar to the following. Structured, right? two-dimensional objects, if you consider them to be that. We have columns and rows. Each row is a given firewall rule, and it can be essentially many rules for an individual server. In this case, they're going to be public IP addresses. So we're gonna store those as an object here. If we're not able to store those approved rules, we're going to get a push and fail dependency. And so we're still just doing all the prerequisites, right? We're establishing our context to our configuration data. But that's what's key here is we're able to access the configuration data inside the Azure function. And those that might be skipping ahead are thinking that if you've ever used Azure files, mount those in your own explorer.exe process, and then that will allow you to manipulate these in Excel very, very nicely, and we don't have to look at JSON again. That's kind of one of my goals in life. And so once we have these allowed firewall rules in memory here, then we go ahead and destruct the file that we actually downloaded. I know that this is shared infrastructure. This is just good practice anyway. And so now we get to the goodness. We have what I would consider to be current firewall rules by just all of them in the environment that represent, remember how we set resource and resource group name came in all the way from the scope at the very beginning. We split the scope to get our resources. And so once we have those firewall rules for that given object, so the current state of that, we take a look at them compared to what is allowed in general. And so if you've ever used compare object before, it is one of the better commands in my commandlets in my book, because it allows you to do property level comparison between multiple different objects. In this case, we're going to see based on the firewall rule name, the server name, the resource group name, what objects are different, right? And basically what this looks at is says, okay, we're going to go through this set of objects now, where we will actually get an indicator on the object properties of equal, less than or equal to or greater than. And so what this means is if we get an equal sign in this return object, we actually say, okay, this firewall rule exists and it's allowed, right? I've commented out this additional set of objects here. We don't really, this is for zero defects, right? To not really have any variable declarations that we're not doing anything with. But if you wanted to do something with this, here's another iterative collection. But here's what's interesting. If our sidecar property looks like less than or equal to, that basically means that the firewall rule exists, but it's not listed as allowed, meaning it's not found on this spreadsheet of allowed firewall rules. So let's look at that as a rule to remove. And of course, you can consider this extra rules, right? Something that maybe exists on the spreadsheet but not in the server, right? That would be more like a set operation than a remove operation. You consider about state configurations. We're not going to explore that today, but their object commandlet allows you to do this. If you can basically state between what is existing in an environment and what is in a configuration document. Their object works really nicely when you import CSVs and you're working with native objects in PowerShell. And so we've identified our rules to remove, and now it's not too difficult PowerShell here, right? Once we've done all the logic, we basically say, hey, if this rule, if we need to remove it, we're going to try and remove it. And so we get the Azure SQL Firewall rules for the one that we're working in, and specify the firewall rule name that is identified as being superfluous, and then we remove it, right? Errors in case something happens. And then I think that is pretty much done. Yep, it's just you push it 200 if we get this far, and then this is our else to basically not receiving any type of scope on the original request. So this isn't extremely complicated PowerShell. I think that the effort in doing this compare object, or making sure that the understanding is here, and making sure that you're grabbing configuration data correctly, and basically that will give integrity to this compare object variable, so that when we iterate through it, we trust these what are called sidecar indicators. So now that we have a decent understanding of the code itself, what I'm going to do, let's go ahead and open up our Azure Functions here. Let's do this. Let's create a new project and create this here in the desktop and call this select. We'll do a PowerShell function, HTTP, and we're going to do set AZ SQL Server Firewall rules. That sounds good. Let's go open it in a new window. So now we have essentially another function to work with inside VS Code, because this is going to allow us to deploy it quickly. And so let's go here inside, and we should run .ps1. This is a standard HTTP trigger template, but as we just looked at, this is all the code that we want. So I'm going to go ahead and do. So I've just copied over the code that we have, and I'll minimize some of these regions. And now we are back at our starting spot again. I think it's worth calling out the reason why we did the system managed identity here in profile.ps1. We are doing the connect AZ. This commandlet only works when you're running within something that has a system managed. If you are deploying from the VS Code and you have this and not commented out, and you're trying to use application registrations and you're getting error notifications, the lack of comments is probably why. It's probably because you don't have the managed enabled. But in any case, this looks good. We'll go ahead and save like I did. Profile looks good. So we'll go ahead and go back into Azure Functions here. And now we'll go ahead and deploy it to our second firewall rule. Let's go down here. 002. You can see that I've kind of done this in the past. Let's just go ahead and deploy the function app. Deploy. Maybe we'll start seeing some output. Yeah. So this is a little crash course in using VS Code to deploy to Azure. If you've never done this, you've gotten the flavor of creating it from the front end using, but now we're actually using VS Code to push it directly from the IDE into Azure. I'm using a couple tools or extensions, the Azure extensions and PowerShell extensions. But you can see we just got a deployment successful, querying triggers. You might get a little bit of a non-terminating error saying the triggers weren't found, but that's okay. And so we'll take back now, and if we actually have a hard refresh this and take a look into the code, and we'll see that we now have this function available to us. This is pretty cool, right? And if we look at the code and test area, we'll actually see the code that we just wrote be delivered there. So excellent, fantastic. Now complete with our first demo. We have done the hard part of this demo, I would say. The rest is all just plumbing, and now it's how to leverage this logic that we've implemented. Take a look now. The next step in this case is kind of to work backwards through this circle. We've created the function. Now we need to create the logic app and do that. What we'll do now is we'll go back home and go into our resource group. And again, I'm just going to use a standard old portal, create a logic app. Let's do this, create. Name here, AZD. This is a app set AZ SQL Server Firewalls. And we'll just call this the second one so I'm not confused. I'm going to keep log analytics off. There's no reason why we need an integrated services environment. You can just go ahead and create this thing. And I'm going to step back to the presentation to call out a couple assumptions here. So again, I'm still saying that this is free, right? Because there's a very, very small cost that's associated with logic app invocations. Like per 10,000, I think it costs 25 cents, right? It's extremely small in this case. But when we create the logic app, now that we have the object, what we're going to be doing is we're going to be setting up an HTTP trigger. We're going to be uploading the alert schema that I know that we haven't talked about yet, but it is backwards like this. We're going to create a control flow that basically evaluates alerts that are going to be coming to this logic app. And then we're going to make sure that we call Azure function appropriately if we receive an interesting alert. And on, I want to again remind you guys that the reason why we're creating a logic app first is because the dependencies, you can't necessarily do the monitor configurations until you have the logic app configurations done. so we're working backwards with some known information that isn't apparent immediately, but I'll show you what that means. When we configure our logic app, the first thing to do is, like I said, we define an HTTP trigger, and we kind of get this initial indication of when an HTTP request is received. And what we have to do here, the main bit of configuration, is tell the logic app what the schema of the request is going to look like. So when Azure Monitor receives an alert, what is that going to look like if it spits it to a logic app? Luckily, I have this available. We can take a look at it individually here. It's a lot of ugly JSON, right? I don't even, it gives me anxiety even just looking at it. We could either copy this in directly, or there's kind of a cheating way to do it. If actually look at a given SQL server, and if we go ahead and look at the activity log, because remember that's the source of everything that we're actually going to be looking at. And let's say, I think I've created this within 2 weeks. There's some interesting updates that are happening here. This is where we would actually be able to go to see if there's a change to the firewall rules. Let's see. And I think that when you create it, I don't know, let's generate some data here. Let's go ahead and add P and say. So now we've just essentially created activity log. I don't know if it's going to be this fast for me to see this here. Yeah. Anyway, what we can do is I'm going to use a fake alert, not the one that we really care about, but the principle still applies. We can go into these events. We can look at the JSON that actually was generated. I can copy all of this JSON because this is what's sent to Azure Monitor. And then what we can do is we can just actually use a sample payload to generate the schema. This is not a very clear thing to click on. This looks more like instructions to me, but this is actually something you can click on to paste in a payload. I'm not going to do that because, like I said, I've actually saved the schema out here, but I generated this schema by actually uploading a payload. So yeah, don't show again, that's fine. We're going to go ahead and press OK save here because this is the main part to do with the HTTP header. If we look back at what our to-dos here in the demo are, we need to create the control flow task and call the function. So basically, the idea is that if we see something that's changed on an Azure SQL Server by anyone other than our function that's doing it, that's approved to make changes to a SQL Server, then we want to invoke our Azure function. That's kind of the logic that we're going to be going through. So look here for a control flow task. There should be a condition. If something happens, do something, right? This is very, very simple logic. And in our case, the specific values based on the alert data that we'll get into later are the caller and the action. And again, I've kind of saved this a little bit ahead of time. So if the alert that's received includes so again, this dynamic content to say, give me the dynamic content from what was the logic app is equal to this operation, doing a write operation on the firewall rules, and the caller does not contain and this is going to be that object ID that I didn't copy out of our managed identity. Caller, because again, we're operating in that context. So this basically says if someone other than our approved callers make a change, then what we want to do is execute our function. And let's see here, this is our 002 function. This looks good. It's going to ask us, do we want to add in a request body? Yes, we do. Remember, we need to include some specific information about what resource was actually being added. And you can see here, the alert scope is going to be looking for the scope element. So I'm just going to take this much to show you guys how dynamic content works. And let's go ahead and add in scope. So again, it's going to take the scope from the alert generated, and it's going to use that, and it's going to pass that to the Azure function. This looks okay. I need to come back and edit this, but I'm gonna save this for now. Full demo, I'll go ahead and fill in this last value. Check our assumptions. Yep. Our databases and firewall rules are already created. So cool. We're done. We're done with our Azure Logic app. We've configured that to basically fit into our plumbing. We've now gotten 2 of the 3 configuration items done. Now we need to turn into Azure Monitor. And so basically what we need to do is now create an alert. So again, it's more plumbing, more a way to get the data out of what the user's been doing and into this world. Let's go ahead and go into Monitor. And we're going to go ahead and create an alert. Maybe the first thing that we need to do, if we actually take a look at my notes again, is in Azure Monitor, we need to create the action group first. So what we're going to do here is create an action group, and I'm just going to demo, and we're going to put this into our second one. We're still going to call this demo action just for simplicity. And what we're going to do is we're going to invoke a logic app, our second one that we just actually did. So if we're basically going to be able, part of the alert scheme in Azure is once an alert's received, what do? We call an action group. So we're defining do. We're going to name it the common alert schema. Again, we're passing that up to the logic app that we just configured. So cool. Now we have our demo action group that should be created pretty quickly. And so now if we go back into alert, the easiest way to do this is actually to create a alert that is, from the same way that I was kind of cheating earlier. I'm going to go into my first SQL server that I've done in the past here, look at the activity log, and I'm going to look for the past month because I know that in the past month I've changed this firewall. Show you guys how you can create an alert. Oh, this first one, right? 2 weeks ago, update server firewall rules. Let's go ahead and create an alert off of this. So you can see it was started versus succeeded. We want the succeeded alert. I can just boom, create a new alert right from it. Huh, that was really easy, right? But the thing is we need to change the scope of things here. So scope this down into let's see, done. This is in general the entire subscription, right? I want this alert to be done whenever any SQL Server firewall rule is changed. I don't know, I didn't get my conditions that came through there. Let's see here. New alert rule. There we go. Now you can see it came through the way it was supposed to. A little thrown off there. You can drill down all the way through here to see exactly which applicable server firewall rules it's going to apply to. Again, what I do here, it shows us all of the resource groups that are inside here, and then if we can drill down, I'm going to just say again, I want all server firewall rules. I'm not going to scope it down inside of a resource group. And then I don't want event initiated by myself. I want event in anyone, all services and users, right? Status succeeded, that's good, right? This looks better, right? This is a little bit more verbose, more things when I do this. Remember I talked about action groups. Now we're going to go ahead and demo action group that's going to call our logic app. And we'll just call this demo rule for shy. Cool, this looks good. I'm going to go ahead and disable this alert rule right now just because I'm not going to have it start quite yet. I'm almost to the full circle demo. But that rule alert has started, and now let's go ahead and go home. And now back at our PowerPoint here, we are including all of the SQL servers from any one that makes a change. And so now we're really close to actually seeing the full demo here. The only thing we got to do is actually upload the list of firewall rules. And so what we need to do now is set up some more, storytelling here. If we look at firewall rules of our virtual, we have our client IP address here, but we don't have one that's named, David Home, right? I'm just going to say David Home. now we have actually 2 rows that have the same information. And I'm going to say rule to remove. I'm just going to add these here, right? Full server from a network layer. And we still have our CSV here that has our approved list of firewall rules. Let's go ahead now and make sure that in our storage account it has our Azure share, that we have our CSV. Configuration documents, cool. I do have one already there. I'm going to go ahead and upload something now. Let's go to desktop here. Yep, we'll upload. So our firewall rules in this space, and there are 2 things now that I need to do. I need to add logic app information from the approved ID things, and then enable the alert. So we'll do those things now, and we'll do our full scale demo. I'm going to grab the object ID, our identity, and I'm going to go into Azure AD here. And let's see if I remember how to do this. Okay. I am just going to use this object ID. And okay, and now let's go ahead and enable our alert and monitor. Be seeing our alerts here. Don't know. Oh, that's why. This is. Come on. When we created our alert rule, where's all signal types? There we go. And we'll enable this. Okay, so now basically the context is set that if I need to take some action, I need to create another rule, or I need to generate activity that basically says that our logic app should be receiving an alert. So I don't know why it didn't enable. Okay, there we go. Let's refresh this again. I don't know why it's still saying disabled there. Something takes just a little bit to enable. Anyway, in theory, let's take a look back at our slide here. I'm going to take some action on the firewall rule. That activity push to monitor. Monitor is going to send it to logic app. Logic app is going to send it to functions. Function is going to check to see whether or not what I just did and any other things we've done in the past are approved. And then it's going to go back and revert those changes. So let's go ahead and test this and kick it off. And while we're waiting, we'll finish up the slides here. So here in number 2, I'm going to simulate. I'm adding another client IP here. Let's go ahead and just add another rule and to say rule 2, 4.4.4. In theory, when I save this, it's going to kick off that process. It takes several minutes. And so with that, hopefully we'll observe the changes here, look at the logs when it's all done. But I wanted to stress that, we've got deep in the weeds in using Azure, and I understand that takes a lot of effort and knowledge and experience, but it's not about the tools. What we're trying to do is basically find the balance of promoting self-service, but being stewards of infrastructure and security. And basically, you can use whatever tools you want, right? We could have done this all with Azure policy. There's a ways we could have written JSON that audits this and remediates this, or deploys if not exists, all that kind of thing. Don't let me stop you if you're more comfortable with that. I don't want JSON my state of JSON files to not elements. You could probably do this in Ansible as well. You could probably catch the stuff at provisioning with Term, right? There's lots of different ways to do this, but it's really about trying to maybe leverage the give and take of security and speed, and making sure that you're not limiting yourself in that way. And however you implement a solution, just make sure that we're achieving the objectives. Right? That's what I'm trying to drive home here. Before we take a look back and see if our demo is completed, I've done my sacrifices in the background here to see if our firewall rules are going to get removed. But knowing permissions of assigned roles is critical here. We're not, a developer is not prevented from creating this point-in-time rule into an Azure SQL database. They are, again, in charge of that infrastructure, but by implementing some of this, we are significantly reducing the clutter of those rules, or the drift in configuration that could accumulate. As I mentioned, we're only removing unapproved rules. We're not actually setting rules that are being desired, but we could still easily build that into our object. And again, this is all driven because we're using CSV to make two-dimensional objects, or at least row and column-based presentation. If you get into objects that have multiple levels of configuration, like multi-level JSON, this does get a little bit more complicated, but it is possible. The code examples that are on my Azure DevOps for Chicago PowerShell demo, and you can find me on LinkedIn and my website. So with that, I can check and see if our firewall rules, when I refresh here, have been removed. I'm hoping that they have been, crossing my fingers, and they haven't. Demo did not work out as well as I thought it would, but let's go ahead and quickly look at why. I'm pretty sure it's probably because the logic app didn't receive an alert, or it's because I didn't set that correct value of the Azure AD principal. You can see it actually hasn't run yet, so maybe we just need to wait for the ether. In that case, I can give you my best promise, guys, that this does work. I use this in my own environment all the time in this framework, and maybe if we jump to questions, we can check back to see if this has worked successfully, and we can look at the logic app run. We are just kind of waiting on the ether for that alert to funnel through the system at this point. And so with that, I'm going to take a check back and see if there were any questions or where we're at on time. And done.
Yeah, hey, that sounds good. We are a little over time, but I think we had two quick questions we kind of like to go through.
Yep.
The first one that I have is early in the session, there was something that connected with a few folks in chat, and it was your concept of kind of like steward for your organization and IT. People kind of like really like the way you. Could you maybe like tell us just a little bit about kind of like what that means to you a little bit more, and how you think about that?
I mean, it goes back to if you attended the keynote, Jeffrey talking about talk to your customer, ask yourself who your customer is. It's not your coworkers, I can tell you that. It's the people that are leveraging everything that you're setting up and architecting. And so we have to enable those that are not as familiar with our day jobs to be able to use our knowledge, right? And so I think that that's where that comes in. We are the experts in our realm, but we have to enable others to use it, and so that comes from the infrastructure perspective. But then security is everyone should be more security.
Yeah, awesome. The second question is, we had some chat about logic apps and Azure Functions and whatnot, and some people mentioned that, hey, I like logic apps, but I get annoyed with them, and then I just write functions. I mean, this is a PowerShell concept, right? So it makes sense. But could you maybe give us some tips on trying to choose the platform in Azure for automation, trying to choose, like, should I start with logic app? Should I do a function? You gonna have any suggestions there when I'm just starting to thinking about building something, what choices to make?
Yeah, probably lean towards functions too. This is PowerShell, right? It's probably our closest. We touch on it, right? I think when you look at logic apps, it's a little outside of a system administrator's standard loadout. It does bring in different service elements. So if you want to orchestrate things really outside of maybe infrastructure, maybe it's API calls, maybe emails, maybe it's interacting with services, or other things like that, then logic apps are better. Or if you wanted to quickly implement conditions, I think logic apps are good. But otherwise, I don't really get too deep in logic apps. I do really simple stuff there, and would tend to stick in functions as well.
Yeah, awesome. Well, think that about wraps it up. I don't see any new direct questions up in the chat. So I think what we're going to do is go ahead and jump back to ads. And we have another session coming right up with Joseph Hughes on GitHub Actions to automate Terraform for Azure. So David, unless that demo has come out of the oven and you wanted to show that quick, I think we'll switch to ads.
No, it hasn't yet. I
Okay.
think that alert has just not triggered yet. So maybe I'll post a screenshot to chat later.
Yeah.
Thanks
All
for
right.
all the support.
We'll take your word for it. So everyone stay tuned. We still have 2 more sessions left today, and they're both looking really, really good. So we're going to go hear from our sponsors again, and we'll be right back in just a few minutes.